In today's notes, we're just going to start with basic vocab and combining like terms. So at the top of the page, I'm just going to read the definitions for polynomial, standard form, degree, and leading coefficient. So a polynomial consists of constants and variables joined together by addition, subtraction, and or multiplication. Constants and variables are grouped together into one or more terms. These terms can be a single number, a single variable, or a product of numbers and or variables with exponents that are non-negative integers. So some of those keywords are in bold. Standard form is an expression that contains no like terms, or an expression is in standard form when it contains no like terms. And exponents are written in order from least to greatest, or I'm sorry, greatest to least. So let's underline that, greatest to least. Degree. The degree of a term is the total of the exponents. So when you're looking at the degree of a single term, we add the exponents. The degree of a polynomial is the highest degree of its terms. Our leading coefficient is the coefficient of the first term of a polynomial in standard form. So let's take a look at this table. And we'll just focus on standard form. So one column and then move to the next. So in standard form, since there's no variables here and there are no exponents, it's just as is in standard form. 9 minus 8x, we switch to negative 8x plus 9 because that x to the first would be our highest exponent. And there is no exponent on the 9, so you can think of that as x to the 0. Okay, and when there's no sign in front, it's just good to mention that the number is positive. We don't say a positive 9 minus 8x or plus 9. If there's no sign, we can assume that it is a positive number. So 5x minus 7x squared, that exponent of 2 is the largest with an exponent of 1. So in standard form, this would be 7x squared plus 5x. And the next one, the 3 is higher than the 1. So as an exponent, so 4x cubed plus 8x. And then in the last row, the exponent of 4 is higher than the 3, and then no exponent, so that negative 3x to the fourth is first. Remember to bring the sign that's in front of the term with it, plus 2x cubed plus 4. Now the degree. As we mentioned, the degree of a term is the total of the exponents. Okay, and the degree of a polynomial is the highest degree of its terms. Our degree here is 0, okay, as we have no exponents. And as I mentioned, you can think of this as x to the 0. Okay, here our exponent of 1, so it's a degree 1. Our exponent here, degree 2. Our highest exponent here, degree 3. Highest exponent of 4, degree 4. And the names. Okay, a degree of 0 or just a number is called a constant. We graph that like y equals 4 is a horizontal line. It remains constant. There's no change in a slope. A degree 1 is linear. Okay, that's kind of like mx plus b. Degree 2 is quadratic from the functions unit. Degree 3 is cubic. And degree 4 is quartic, Q-U-A-R-T-I-C. Number of terms. Okay, terms are separated by addition and subtraction signs. So here we just have the one term. Here we have 1, 2 terms. The next one, 1, 2 terms. 1, 2 terms. And then the last one will have 1, 2, 3. Name by the number of terms. We have a name by degree, a name by number of terms. Okay? An expression that just has one term is called a monomial. That prefix mono for one. So the next three, okay, a name for a polynomial with 2 terms is called a binomial. Bi for 2, and then for 3 is called a trinomial. and try for 3. Anything greater than 3 terms, we're just going to call a polynomial. It has no special name. Leading coefficient. Well, we have no leading coefficient in the first one, as it's the coefficient of the first term of a polynomial that's in standard form. So our leading coefficient here is going to be the negative 8, here 7, here 4, here negative 3. So that term right in the front. So negative, or that coefficient of the term, 7, 4, negative 3. So down below, we're going to look at the parts of an expression. Okay, break it down into the terms coefficient, base, and exponent. The base is what is attached to the exponent. Okay, so these are grouped together where the coefficient's out in front. So here's the part of that term with the exponent, and then here, this does have an exponent attached to it. Okay, so this has no coefficient out in front. This one has a negative 5, and this one a 3 in front of the x squared and b to the negative 3. The base, okay, we raise the base to the power. Okay, the exponent is attached to the base. So here we have a base of x, here a base of b, and here the base is 2. And then the exponent, we have a 2, negative 3, and 3. Anything that's numeric, like 2 cubed, means 2 times 2 times 2, or 8. Okay, we usually write it as 8 and we don't leave it as 2 cubed. And now we're going to finish by combining like terms. So before we do that on the back, looking at the vocab, like terms are terms that have equivalent variable parts. Variables and exponents are the same. So let's underline that. Combining like terms means to add or subtract the terms that are like, as it says, combining like terms. Write the answer in standard form, and we keep, okay, so let's make note, we keep the variables and exponents the same. So on the back, at the top, it just says, look at each pair of terms and decide if they are like or unlike terms. So A, we have an x squared term and an x times x. Well, that's the same as x squared, so these would be like. We're just focusing on that variable and exponent piece. Moving right underneath, we have x to the 4th and x cubed. That would be unlike. A cubed and a cubed, that's like. xy and yx, that's like because multiplication is commutative. You can change the order and you still get the same answer. So xy is the same as yx, and 3xy and 2xy would be like terms. 4x, 7y, those are unlike, and then a and a would be like. So we're going to, in the expressions below, a through h, just go ahead and combine like terms. So in a, we have 10xy and 7xy. We're only combining the coefficients out front. The xy stays the same. So 10 plus 7 is 17, and we leave the xy. Same below, we have a negative 5 minus 3, which would be a negative 8. The s stays the same. When we have grouping symbols, we need to remove them. And when you add a binomial or distribute the positive sign through, that does not change the signs. The only time the signs change is when you're looking at subtraction. Okay? So here, if you look, adding left to right, negative 8 plus 3n would be negative 5n. Add the last 8n, and you get 3n. If you notice right up front, this negative 8n and positive 8n are inverses, so they would cancel out, and we're left with 3n. C plus c, you can think, again, if there's no coefficient written, it is a 1. So 1 plus 1 is 2, keeping the c. So down below, we have an AB term and A terms. Since there's no other AB term, we can only combine these two. So I'm going to bring along the negative 3AB, and then combine negative 10A minus 8A. Negative 10 minus 8 is negative 18. Bring along the a. In f, we have an x squared y term and another x squared y term, and 7 minus 5 is 2, keeping the s squared y. And then 8 plus 4 is 12. In G, I'm going to combine in alphabetical order. So the A's, I have 7 and 4, which is 11. Now the B's, a positive 5B minus 3B would be a positive 2B. And then last, there's no term to combine with the C, so we just bring it along. And at the end, I will also combine in alphabetical order, m's before n. I see 4m and a negative 4m, so those would cancel. And then a positive 13m and a negative 13m, those would cancel. And then last for n's, a negative 7n and a positive 7n cancel. So if everything cancels out, or it's the additive inverse, the answer is 0.